Hello, everyone. Welcome to our seminar, New HDF5 Features Coming in 2020-2021. My name is Gerd Heber, and I'm at the HDF headquarters in Champaign, Illinois, with my colleagues John Mainzer, Dave Young, and Gerd Heber, who will be helping with presentation. Also with Lori Cooper, who is our organizer, and she will be helping with recording, etc., and you will be hearing from her. The seminar will be recorded. So today's topics that we'll cover are splitter mirror VFDs. We will give you introduction to the design and the problem we're trying to solve and show the demo. Also, there will be demo of VFD SWMR, and then we'll talk about sparse data management in HDF5. You will be able to use GoToWebinar control panel to ask your questions, and we will try to answer all questions at the end. But if not, we will answer the questions and we'll post the answers on our forum. Then at the end of the seminar, we would like to have very short poll. You will be able to click and choose, make your choices. We're trying to find if there is more interest in discussion of the features, if you would like us to present more technical details about implementations and design. So please participate in this poll. So that said this, did I forget anything, Lori? Okay, so let me move forward to our first feature, and I will give a very brief introduction to splitter and mirror VFD, and then John will continue. The problem we're trying to solve is to make HDF5 data available on a remote system for reading while creating a file on a local system. This is a very pretty well-developed feature, and we are ready to merge it and release it in the next maintenance release of 112 branch and 110 branch. And this should happen before June 2020, so in the next 2 to 4 months, 6 months, depending on our release schedule. And our future plans, and I'm sure John will touch base on it, we will be working on optimizing the feature for HPC environment and trying different things, but it's mature feature, it's ready to go and ready to be used. With this, I will ask John to continue, who will explain design of the feature.
Okay, so mirror VFD is really pretty simple. You can see in the diagram here. We've taken our existing VFD stack and inserted an extra splitter VFD, which takes all writes and copies them over to the mirror VFD sender. Now on file open, the sender will contact the scheduler on the target remote system, which will create a receiver process which handles all of the communications. Then what happens is the HDF5 library does writes. In addition to being sent down to a local file system, they will also be relayed across to the remote system, which will then perform those writes with whatever VFD is selected on that side. So at that point, we should probably go to a demo. May I have screen, please? Okay. Should be coming up shortly. We try this again. So, there we go. All right. So what I've set up on these windows are the two windows on the local system, and over here we have the windows on the remote system. First thing I'm going to do is start the server on the remote system. Now over here on the local system, what we did is we took an existing regression test for our existing swimmer, and we modified it slightly so as to insert the mirror VFD in its VFD stack down at the bottom. So I'm going to kick this one off. We'll have to wait a little bit as we need to let it get to the point where it's shifted over to swimmer write mode. Then I will start a local reader here, which will read the local version of the file, and also a remote reader, which will show you that it's reading the remote copy of the file in real time. Okay, so let's kick that off. That has started as a writer. So there's the reader locally, and there's the remote reader. And we'll let this run to completion, which shouldn't take too long. And then for the more suspicious amongst you, I'll do a checksum on both files and do a partial dump. Okay. There's checksum there. So that's a quick demo of the use of Mirror VFD. I should emphasize that the current implementation is mostly to demonstrate the capability. It's not particularly high performance. If there's interest, I'm sure we'll be working on higher performance versions. For example, the splitter is not particularly efficient, and also we can use different transport mechanisms.
Thank you, John. Please post your questions if you have in the control panel window that we'll address at the end of the seminar. And now we are going to the swimmer introduction and demo. And now you should see my screen again. So the problem we're trying to address is we have to remove limitations of the current swimmer implementation. Just to remind you, current swimmer can only append data to existing data sets. One cannot modify file structure, cannot add or delete groups, for example, data sets or attributes. So we would like to enable swimmer to allow modifications of file structure. We would also like to support variable length data types that are mostly used, for example, in streaming some sequences at the time series into HDF5, or some variable length type of strings like market data or buyer data, or some experimental data that really is not fixed in size by nature. We also want to relax the order in which writer and readers come in. As you saw in a previous demo, John had to wait a little bit before starting reader, otherwise writer will not be able to do some things in some cases. We also would like to remove POSIX semantics, that requirement for write atomicity that is really affects our ability to use swimmer say on the systems that are not POSIX compliant. For example, with current swimmer implementation, we cannot provide NFS support, which is very important for many of our customers. We also would like to guarantee maximum time from write to availability for read, and we, of course, making this assumption that file system is fast enough. And if you want to know more details, that's why we're asking for Paul, if you want to listen more about this and how we deal with this assumption. And we want to remove performance penalty for applications and minimize maintenance costs for the feature. So our demo will focus on two limitations. It is modification of file structure and to show you how quickly reader can see data written. And with this, I will pass it to my colleague, David Young, who will show us the demo of new swimmer implementation. Just give me another slide to talk about status.
Okay.
Right. So our plan is to release the feature in 2021, and we hope that prototype will be available for testing during 2020 for friendly users. We really want to release it as quickly as possible. We'll clean the code, document assumptions under which it works now, but you should be able to try it pretty soon, like by the end of this year. And our future plans will be to study performance advantages of current swimmer and this swimmer, and decide which swimmer will be supported for the long time. And at least for this swimmer, we are looking into extending current prototype that is working to a network file system and to cloud. And with this, I will let Dave to show the demo.
Okay, I've prepared two demos for VFD SWMR. The first demo shows the new capability to create and destroy both groups and data sets while the reader observes the changes in real time. The writer I've called Cradle. It creates and deletes the groups and data sets. It's going to print the groups and data sets as it creates and destroys them. At any moment, there should be no more than 2 groups that it's created. Each of those will contain no more than 2 data sets. The data sets are written with a pattern of 1s and 0s, and that pattern rotates. I will use H5LS to observe the file. H5LS has a new option, --poll, that specifies a poll interval. I've written a little script to start H5LS for me. I ask H5LS to open the file once and reread it at 100 millisecond intervals. Let's start that script. You can see that the group and data set numbers on the writer and the reader are not very far apart. So H5LS is actually following pretty closely the writer. You can also see the data crawl here. So that's the first demo. So this is, a new capability that we have with VFD SWMR to create and destroy groups. Let's look at the second demo. All right. The second demo highlights the real-time capabilities of VFD SWMR. In this demo, the writer synthesizes 2D data frames and adds them to a data set at 30 frames per second. Let's start the writer. You can see that it's displaying the frame that it's writing at the current time. It doesn't display the frame itself. The reader visualizes the frames as quickly as it can read them. Let's start the reader. You can see that the visualization is no more than a few tens of frames behind the writer. We can pause the writer, rather pause the visualization, and then let it restart, and it's going to skip to the last frames written. So that's the second demo I have prepared today. Let us know if you have any questions about that.
Thank you, Dave. And now we are going to the last part of our webinar. We'll talk about Sparse data management in HDF5. And we would like to provide, HDF5 was designed mostly for dense array. So we would like to provide some native way to provide efficient sparse management data in HDF5. And we would like to do it as natively to HDF5 as possible. For example, you continue to use current APIs with some maybe extensions to APIs we have. We are in design stage, and we're soliciting feedback from our community, and Gerd will talk more about design options and what we learned while we were working on those design options.
Thanks. Okay. Yeah, next slide, please. Okay, I'm going to start with a quick motivation. I'm not going to talk too much about use cases. There's obviously plenty of sparse data out there, and I'm sure each and every one of you has plenty of examples. As far as the HDF5 data model is concerned, as all of you know, there is no concept of sparseness. And at the model level, a data set is sort of a rectilinear, dense structure, and let's say for scalars, how many non-zeros or zeros there are not material. You can, of course, improvise. That's one of the nice things about HDF5. You can improvise almost anything, including to deal with sparse data, and you can use, or in some cases, abuse existing facilities. For example, depending on how sparse your data is, you could try an approach where you use chunked storage layout and compression, and that way, at least as a storage, achieve certain savings. But then, of course, nothing prevents you from mimicking sparse formats like row compressed storage or column compressed storage, or there's a whole zoology of sparse formats out there. You can certainly put that into an HDF5 file, and those are all legitimate uses. And this is here not really about right or wrong. There is no right here. It's just whatever works for you. And however, these sort of more ad hoc or special use case scenarios, they have some common side effects. So, for example, it might be difficult to determine in your sparse data sets which entries are really defined, which are present, which are non-zero, or since we are supporting pretty much arbitrary types, we call them defined entries rather than non-zeros. And a more difficult problem is, of course, that if you choose to represent your own layout, like the row compressed storage and so forth, you are in a way breaking away from the existing tool ecosystem, in the sense that, yeah, then you are obviously not preserving the array abstraction. So in the simplest case, you have a matrix with which is a two-dimensional data set in HDF speak, but then, of course, if you represent it as three one-dimensional arrays, then the standard tools in the ecosystem won't recognize it as that sparse thing that you have in mind. And so it's sort of this tension between ad hoc and more generally applicable solutions. Next, please. Thank you. So we, as with many of these efforts, you have to collect your requirements, and our requirements for this design were the following, or these are the most important ones. Number one is we would like to preserve the abstraction for a variety of reasons, but last but not least, to maintain interoperability with the existing ecosystem. We would also like to be able to access these sparse data sets through existing HDF5 APIs. Of course, there will be some API extensions that are tailored to these sparse scenarios, for example, determining the defined entries in such a sparse data sets and return appropriate selections and so forth. But still, existing APIs that we have in HDF5 today should just continue to work with these sort of more specialized data sets. Of course, we would like to achieve appropriate reductions in storage space and I/O time, and storage space on disk, but also in memory, that is, and I/O time We would like to support random access read-write operations for these sparse data sets, and certainly we would like to support all that in parallel. However, of course, if we look at this from a development perspective, I think the first prototypes or early versions of this you will see most likely will support serial mode, but then in the long term we definitely want to support this in parallel. And then you can think about, well, what are sort of in broad brushstrokes the design options, and you can break them out into two categories. I would suggest one is, you might call them weak options, which means that you're trying to stretch the existing design and try to make do with what you have, or what I would call strong options, where you acknowledge that maybe we should treat these sparse data sets, at least from an internal HDF internal implementations perspective, as something fundamentally different and treat them accordingly. Now, on the weak options side, of course, there's the status quo, and I spoke about that briefly earlier. You can try to use chunk data sets and compression, and that will give you certain savings in space and time, maybe. It will not give you many savings in memory, however. Another approach would be to consider the filter pipeline that is very flexible and, for example, filter out non-zero values and then get certain savings in storage. And then, of course, what I alluded to earlier with the emulating a sparse format in the existing HDF5 capabilities amounts pretty much to implementing a high-level library if you want to make that convenient to your users. And then sort of the main strong options where you treat sparse data sets as something fundamentally different would be, of course, internally, B trees are widely used in the HDF5 library, and that would be an option to store very sparse data sets. Another option that we will talk a little more about today are so-called sparse chunks, where you are basically saying, well, the idea of chunks or tiles is actually very useful, and we could overlay some kind of selection on top of that, at least from a sort of user's perspective, and then that way identify defined entries on such a chunk, and then you just call that a sparse chunk. Of course, that doesn't mean we store traditional chunks the same way we store dense chunks in the library, but then again, this is an implementation detail and shouldn't really concern users too much. Or, of course, you can always say, if you have an unlimited budget and plenty of time, you can completely start over, and then, but that's not without risks either. Next slide, please. So if you sort of want to do a rough comparison of the advantages and potential downsides, we listed here the approaches in the left-hand column and then sort of sketched out the main pros and cons. With the status quo, HDF remains the way it is today, and of course, the main disadvantage with sort of doing that chunking compression type approach would be that that works reasonably well only if A, your compression is doing well, should you use compression, and B, if the data is not too sparse. The second option, using the filter pipeline, will certainly deliver storage savings, so in the spatial dimension. The problems are that, of course, you're not going to gain anything in memory because you will still have to represent explicitly all these zeros. And then, of course, there are issues with efficiently determining these defined or non-zero entries. So that is a potential downside. For the high-level library approach, you will definitely get the savings in space and time, and that's why sort of these popular sparse storage formats, they work and people use them. There's absolutely nothing wrong with that. The only downside from the perspective of our requirements would be that, yeah, we are destroying the abstraction of the HDF5 data set, and that way that's pretty disruptive to the ecosystem, the tooling around it. And then switching over to the B trees, certainly you can expect space and time savings. The only problem could be that if the sparse data set is not too sparse, so of course sparseness is a matter of degree rather than necessarily of kind, so that may work well for extremely sparse data sets, but not so well for only, let's say, medium sparse data sets. And then, of course, the usual parallelization issues with sort of tree-based algorithms. And then, as there are many sparse formats, there are many different tree types that might be more suitable for one or the other type of sparseness, and then you are opening a whole other can of issues. Sparse chunks, certainly the space and time savings would be there. There are potential issues. We have a lot of experience supporting selections and all kinds of combinations of selections with existing data sets in HDF5, and we are certainly familiar with the issues around complex selections and managing them efficiently. But again, since we have a lot of experience there, that might be manageable. And last but not least, from scratch, of course, that's the perfect solution always, but the risks and the uncertainty in terms of cost and budget and delivery are just not really worth pursuing, we think. Next slide, please. If you want to pursue a design like sparse chunks, for example, what's of course prudent to do is do some computational experiments to try to build some confidence into an approach. And what we did is we just took a sample problem and built some kernels around, some IO kernels around that, and evaluated that along certain metrics. So the sample problem is basically picture a stream of images. So you have two-dimensional frames, and then rather than acquiring sort of the complete set of full frames, what we do is we only periodically acquire or store a full image, and in sort of the intervening frames, we are just looking at what we call a region of interest, which is a rectilinear region that falls into that image, or clusters of individual pixels or small sets of contiguous pixels that we acquire. And we have written sort of kernels that write and read back such data. And then we looked at compared to the baseline, and the baseline in this case would be to acquire full frames over time, to look at what kind of speed up can we achieve in terms of write and read speeds, what the space compression, so how much smaller are the files that we generate, and then also keep an eye on what is the ratio of metadata to data, because for region of interest, for example, the metadata is very small. You basically store the pixels in that rectilinear region, plus sort of one corner, plus the width and height of that rectangle. But that ratio is much more unfavorable for these clusters of pixels where the shape could be weird. So here are some sample results, and I'll come back to that in a moment. We will present a paper later this month at a conference where we have more results along the line. So here on the left-hand side, you see what we call the ROI kernel, where we just look at regions of interest, and then there are the numbers. The symbolic here is ROI1, that the number stands for the color depth, so 1 byte, 2 byte, 4 byte color depth here, and this is a typical box plot, so there's some scatter with some outliers and so forth. But you see, you can get, and by the way, these regions of interest cover 10% of the full frame. So just as a rough estimate, you might say, well, I would be aiming for a reduction down to 10% of, I mean, ideally And you see, you get some decent write speed up here, you get a decent read speed up, and likewise space compression, so comparing to having recorded full frames all the way through to these interleaving frames only. And then you see, yeah, the metadata to data ratio is very favorable for ROI. I mean, there's virtually no metadata for the data that you write, but that picture changes somewhat if you switch over to these clusters of pixels. You still achieve pretty good write speed up and read speed up. The space compression is also pretty good, but then of course the metadata to data ratio changes dramatically, and you see sort of this calming effect of color depth, because color depth means your data gets bigger, and then of course, yeah, the metadata to data ratio becomes a little more favorable. Next slide, please. Okay, what are the next steps? We have quite a few use cases, but we are always interested to find more, and so please send us your use cases if you are interested in sparse data management. The paper I was referring to will be presented at XLOOP 2019, which is part of supercomputing this year, and there will be an RFC forthcoming that describes the design and so forth, and yeah, we will step up the community engagement before we embark on any kind of implementation or prototyping. And then this effort, next slide please, was actually funded by the DOE EOD HDF5 project. Thanks to them. These experiments and the design and so forth is due to many people, Quincy, Seren, and Mark Paterno, and then in the implementation we use Stephen Varga's H5CPP. And here at the HDF Group, John, Neil, and Elena and myself were sort of the main people involved. Thank you.
Thank you, Gerd. Please, we don't see any questions. Please don't hesitate to type your questions in the control panel window, or you may contact the presenters. You have emails on the first slide. Don't hesitate to contact them directly if you have any questions. And with this, we will have our poll now. Please take a few seconds to take part in the poll. Probably another 10 seconds. Thank you. The next question. We would like to find friendly users who will help us to test and give us feedback on our prototypes before we release them. So your help in testing and your ideas is extremely helpful. Okay, thank you very much. And we have one more slide with announcements of about our future plans. We announced HDF5 1.12.0 alpha, first alpha snapshot. It is available for download. Please try it and give us your feedback, and stay tuned for webinar. We will give overview of HDF5 new features in 1.12 series of releases that will be supporting in that major release. and especially the ones that are available in 112.0. And also on November 19th, this is Tuesday, we have HDF5 BAF at Supercomputing, and we're inviting you to participate in BAF. Please join the BAF, spread the word about BAF. If you cannot come to your colleagues, maybe they will come. And we're still looking for people who will give us lightning talks. It's 5-7 minutes talk. How you use HDF5, your failure and success stories, your suggestions, and so on. We'll be very happy to see you there. Thank you very much. And with this, if there are, let me ask if there are any questions that people just want to ask us right now. We still have time, and we can answer questions. 30 seconds, and then we'll adjourn if there are no questions. But please don't hesitate us to contact us directly. And, oh, here's a question. Yes, there will be a copy of the slides, will be posted, recording will be also posted. Stay tuned for Lori's email, it will be on forum, right?
Yes.
And it will be also sent to the participants.
Yep, we'll send it out to everyone that registered and post it on the forum.
Thank you. Anyone?
And if they were interested in prototyping, or if you didn't get a chance to vote in the other poll about a more in-depth webinar, email Elena or myself. You'll be getting my email with the slides for this. Just let us know, communicate with us, and we'd be glad to help out and get you on those lists.
Thank you very much for participating, and thank you very much to everyone who helped to organize the seminar and present. Thank you, guys.